Hello and welcome to this video on writing ionic equations. This is a key skill for the GCSE chemistry specification and will support you with key stage 5 chemistry in either A-level or IB. So what this is really is looking at equations where a chemical reaction has reactants that are aqueous ions that are going to come together to form something that is no longer aqueous. So the mobile ions that are present in the solutions are likely to form a solid precipitate. This will allow us to write a general equation that will be applicable for the formation of this precipitate from a range of different reactants that contain the active ions. So the first thing to consider of this is what steps are we going to take in order to complete this process. We're going to try and follow 4 steps. We're going to write out a full equation, including state symbols. It's important here that we balance the equation. We're then going to separate out any aqueous solutions so that we can see the dissociated or separated ions. These are going to be useful for working out our overall ionic equation, but this also provides us our full ionic equation. We're then going to cancel out ions that are present on both sides of the reaction. So we'll note these down. These are spectator ions. They're present, but they do not take part. Then we're going to write out the equation with everything that's been removed, taken out. So we just have our remaining ions, and this is my net ionic equation, the one that questions will typically be looking for. So let's look at an example. Here we have an example question. Aqueous silver nitrate, AgNO3, reacts with aqueous calcium bromide, CaBr2, to form a silver bromide precipitate. Remember, a precipitate is a solid, so this is AgBr, and aqueous calcium nitrate, CaNO3, 2. You need to work out the net ionic equation and identify any spectator ions. So the first step of this is always to write out the full equation, including state symbols. And if we're not sure how to do our ionic formulae to work out what it is, there is a drop and swap technique that you will need to use after identifying the ions that are present. So what I'm going to do is I'm going to write out the full equation for you now. Okay, so here is the full equation using the ionic formulae given in the question. So the first step is we need to balance these. You'll notice that your AgNO3 and your CaBr2 are going to AgBr and CaNO3 too. What I would notice with this is that there are 2 bromide ions on the left and only 1 on the right. So I'm going to have to double this. So I've got 2 of those. There's also only 1 AgNO3 on the left, and I've got 2 on the right, so I'm going to double this. If I look at that, I can see I've got 2 silvers. I've got now 2 nitrates. I've got 1 calcium, and I've got 2 bromide ions, okay? So we can see all of that is now balanced. I'm just going to remove some of those lines. And then you'll notice that the last thing I said we have to do, and I've only added it for the first one, is state symbols. These are all aqueous at the beginning. Our reactants are aqueous. My precipitate is going to be a solid. That's really important to pay attention to. And then my other product is also aqueous. So that's our first step. We've written out the equation with state symbols and balanced. So then we move on to the second step, and it says separate any aqueous solutions into dissociated ions. Now when we're doing this, what we are focusing on is anything that says AQ. Okay, so that will give me my silver nitrate, my calcium bromide, and it will give me my calcium nitrate. So when I write this out, I'm just going to do this reasonably quickly. So I'm going to have 2 lots of Ag plus, and I'm going to have 2 lots of NO3 minus. So that 2 at the beginning, that 2 multiplier for that compound is for both the ions. I've got 2 lots of AgNO3, so 2 lots of Ag and 2 lots of NO3. Both of these again are going to be aqueous, so I'm going to keep those there. I'm then going to do my next thing, so that will be my calcium bromide. When I do this, calcium is in group 2, so I get Ca2+, and I get, now here I've got a little 2, so I'm going to have 2Br-. Now, since this is a little number, it only applies to the ion that it is attached to. So I've got 2Br- but only 1 calcium. As I continue, you'll notice that the next thing is a solid. So when this goes on, I'm going to have my 2 lots of Ag, Br. They don't separate because they are a solid. So they remain there. The last bit will be plus 1 Ca2+. Ca2+, that is aqueous still. And 2 NO3-, 2 nitrate ions, for the exact same reason that that we had the 2 bromides earlier. The 2 is small and it is only associated with the nitrate. Okay, you can see that 2 down here. It is on the outside of the bracket, so everything inside the brackets gets doubled. I've got 2 NO3- ions. So that is step 2 done, the full ionic equation. Job done. If it asks for a full ionic equation, we could stop there. Because it asks for a net ionic equation, what I need to do is I now need to work out just the things that have taken part in a reaction. So what I'm going to do is I'm going to look through it, and I'm going to look for anything that is identical on both sides of the equation. And I'm going to look for anything with sort of between the pluses. So I've got my 2 Ag pluses there. I don't have that on my product side. I don't have Ag plus on its own on this side, so I can't do anything. So I'll remove that yellow line. I'm then going to look at my 2 NO3s. Well, I have 2 NO3s here. So because of that, I'm just going to cross those 2 out because they are the same on both sides. And then look at my Ca2+. I've got Ca2+ here. So again, cross those out because they are common to both sides. And then I've got my 2 Br-, but again, there's no Br- on its own. So because of that, I can't do anything. So I leave it. So that means I've gone and I've crossed out anything. Now, here what I might do is I might note down what I've crossed out. So I might go Ca2+ and 2 NO3-, that's what I crossed out. These are my spectator ions. So spectator ions. I might note that down there just because the question has asked for them. Again, I might just put in good practice, state symbols here and here. The final step is to take the things that have not been crossed out and to use those to form my complete or my net equation. So that is going to be 2 Ag plus aqueous plus 2 Br minus aqueous, and that is going to form my 2 lots of AgBr, and this will be a solid, and that is my net ionic equation. Okay, so again, just come back into the steps so you can see them there. All the working out that we went through on the way to finish off with this equation, which is 2 Ag plus 2 Br minus forms 2 AgBr solid.